All right, hey everyone. Today was day 13 of Advent of Code, and today was all about finding reflections. So we're giving input patterns, and each position in the pattern it either has ash or rocks at this position. And then we suspect there's some mirrors in these uh, grids, and we want to find them. So for example, for the first input pattern, it turns out there might be a mirror at this between position 5 and 6, and always everything to the left always looks like a reflection of the positions to the right of the mirror. Similarly, in our other input pattern, there might looks like there's a mirror between line 4 and 5. So line 4 is equal to line 5, and line 3 is equal to line 6, and line 2 is equal to line 7. So there's probably likely that there's a mirror between line 4 and line 5. And for the first part, we just want to find the positions of these mirrors for each input, and then just our solution will depend on how many lines are above or how many positions are to the left of the mirror. Okay, so how can we do that? So for the solution of the puzzle, we will keep track of positions as a tuple of two integers, and the pattern then will be a dictionary that maps each position to a boolean, whether there's a rock at the position or not. Then we can parse the lines. So we'll keep track of a list that contain all the patterns we found so far, and then we also have a current pattern, and the current pattern will start as an empty dictionary, and the current y-coordinate will start as 1, so because the lines in the example are numbered, we're starting with 1. So then we go through all the lines. If the line is empty, that means our previous pattern just stopped and there's a new pattern starting. So we add the current pattern, we append the current pattern to the list of all patterns, and then we start a new pattern. So we set the current pattern again to the empty dictionary and the current y-coordinate again to 1. Otherwise, we go through the line and we enumerate it to have access to the x-coordinate, and then the position will be a rock if the character is equal to this number symbol, and then we save whether the position is a rock or not to this current pattern dictionary at the correct position. Okay, after each line we need to increment the y-coordinate, and then at the end we need to append the current pattern to the list of all patterns once more to also keep track of the last pattern. Okay, and then with that we can find the reflections. So in order to find the horizontal reflection, what we'll do is we consider potential y-coordinates for a reflection, and this will be in this range starting at 1 and ending 1 before the maximum y. And then for each y-coordinate, we just check if this particular y-coordinate is a horizontal reflection or not. If it is, we return the y-coordinate. Okay, how can we check if something is a horizontal reflection? So we just go through all the coordinates in the pattern, and then the other y-coordinate of the reflection will be given by this formula. So for example, if y is equal to the reflection y, then this would just give y plus 1 as a reflected y-coordinate. And then if this new position is not in the pattern, that's not a problem, we just continue, that is allowed. But however, if the pattern at these two positions is different, then that's a problem. That can't be the case if it's a valid reflection. So in this case, we return false. In order to find the vertical reflection, we can do a little trick. So we can just transpose the pattern. So for each key, we just switch the order of the coordinates, and then we can find the horizontal reflection based on this transposed pattern, and this will give us the vertical reflection. This will allow us to solve the problem. So we just go for each pattern, and then we try to find the horizontal reflection. If we find one, then that will, as we are told, contribute 100 times the number of lines above to the solution. Otherwise, we find the vertical reflection, and that will contribute the number of lines to the left of the reflection to the solution. All right, we can test this on our test input. That looks good. So we can also run it on a real input, and it also turns out it gives us the right solution. For part 2, it turns out the mirrors have some smudge in it, so the reflection is not exactly correct, but the reflection the mirror produces has one mistake in one single position. So now we want to find these new smudged mirrors, and yes, so the code for part 2 is very similar to part 1, but this time we just want to try to find this smudged horizontal reflection. So for this, we want to check if a particular reflection is a smudged horizontal reflection. And here again, the code is very similar to part 1. The main difference is that if the pattern at a particular position is not equal to the pattern at the other position, then we don't immediately return false, but we just count the number of differences. So we add 1 to this number of differences variable. And then if there's more than 2 differences, we know that their reflection is definitely not valid and we can return false. Otherwise, if we went through all of them, if the mirror is actually smudged and there's a difference in one position, then the number of differences should be exactly 2. So it's 2 and not 1, because the position will appear once on the left-hand side here and once on the right-hand side. So we're looking for y-coordinates where the number of differences is exactly 2. Yes, so with that we can find the smudged horizontal reflection. We can again do the same trick as before to find the smudged vertical reflections. And then we can solve the problem by again going through all the patterns, trying to find horizontal reflection and otherwise trying to find vertical reflections. We should also run it on the test input. So if we do that, that looks good. So those gives us the right solution. On the real input also turns out it gives us the right solution. Okay, that was it for part 13. I hope you enjoyed today's puzzle. Best of luck in the future and I'll see you around.